Welcome to this Sketching Transform Boundaries video lecture. In this lecture, we will examine the relative motion between plates at transform boundaries. At transform boundaries, two plates are sliding past one another, like so. There you have it, just one sliding along past the other, nothing going under or over, just side to side. In the case of transform boundaries, it doesn't really make any difference whether the plates are oceanic or continental, so we're not going to break this boundary down by crustal type. In fact, it actually doesn't make a lot of sense to draw transform boundaries in side view at all, because we don't really learn anything that we can't already see in the map view. There are no major topographic features like trenches or ridges or other mountains, only the fault itself, which is actually easier to see in this map view. In fact, I'm going to skip drawing the side view altogether and continue on to the 3D view where I can show you how little we would have gained from drawing this out. Here it is, 3D view, and now you can see that if you flip the map view on its side and just look at this part here, all you would see are two plates with no up, no down, no layers. One is moving away and the other is moving toward, which is actually kind of difficult to represent in side view, so we're just not going to do it. Instead, we will stick with map view images anytime we're talking about transform boundaries. One thing that I do want to note about transform boundaries, though, is where they're found. Because while they are definitely found on land, the San Andreas Fault is a really famous example, the most common place for these type of boundaries is actually down at the mid-ocean ridges, interspersed between the ridges. This happens because the ridges themselves are actually spreading at slightly different rates, and something needs to be able to take up that offset in the motion, and transform faults are able to do so. So the motion on this transform fault would be the same motion as the material being pushed away from this ridge, so moving that way on one side of the fault and this way on the other side. Okay, at this point we have been through all of the various types of plate boundaries. Continental-continental convergence, continental-continental divergence, continental-oceanic convergence, oceanic-oceanic convergence, divergence there, and oceanic-oceanic convergence. So we've been over each of those types of boundaries along with all of the features that are associated with them. Hopefully you can both describe and sketch each one. Go ahead and give it a try.